In this video, we're going to take a look at the concept of redox reactions. Before we go into definitions, let's take a look at a common reaction that you may have seen before in grade 11 chemistry. In this reaction, we have some copper metal in a solution. It's hard to see in this image, but it's dipped into a solution. So the solution is actually a solution of silver nitrate. So we have silver nitrate like this. And then we have this solid copper metal here, which is Cu, solid. And this is what's happening during the reaction. So we're going to have a reaction go. And you'll see this solid deposit on the copper. And that solid, that's actually silver. It's actually solid silver. You might recognize this as a single displacement reaction, where the copper kicks the silver out of the solution. And now the copper goes into the solution and the silver comes out of the solution as a solid. So we have something along the lines of some copper nitrate now, because the copper nitrate has gone to the solution. It's dissolved in there. And it's copper 2 nitrate plus some solid silver. And if you analyze the image closely, you'll actually see evidence that there's actually copper in the solution now. Try to think about what that evidence is. If you picked up on the change in the color of the solution, that's exactly what it is. You see that blue color? That comes from the copper. But anyways, we have a single displacement reaction. This is the equation that describes this reaction. I'm just going to balance it. And it looks like to balance it, I have to put a 2 here and a 2 here. Now, what I'm going to do is I want to focus on the ion movement, because this reaction deals with ions, right? That's how this reaction is happening. There's an aqueous solution of ions, and then ions are being sort of kicked out and transferred into the solution. So remember from grade 11, anything that is aqueous, you can separate. So we have 2 silvers, and the charges of silver from the periodic table is silver plus 1. And then we also have, because of the coefficient of 2 here, 2 nitrates. And those are minus 1 each. Solids stay as is. There's no charge on this solid because it's not the ion, it's just the pure metal. Our arrow there, and then now on this side we have the copper 2 plus, aqueous, plus still 2 nitrates, aqueous, and there's 2 because of this subscript here. And this time the silver stays as is, 2Ag, solid. So this is the total ionic equation. It's showing you essentially all the ions that are involved in the reaction. Now remember, you can do the net ionic equation, meaning you can show what the overall reaction is, because some ions are not really doing anything. They're simply spectators. So to do that, what you do is you take a look at both sides and you cancel out whatever appears on both sides exactly the same. So if you look over here, we have the nitrate appearing exactly the same on both sides as NO3 minus. That means it wasn't the solution before, it was the ion, and remained the ion. However, you'll notice that, so we'll cancel those out. That means these are the spectators. Spectator ions. They're there, but they're not doing anything in this reaction. Spectator ions. We have NO3 minus. Okay. So now we're going to rewrite this with just the stuff that did change. So we had Ag was initially in a solution. And then we have Cu, solid. And then on the other side, well, the copper went into the solution. So copper is now copper 2 plus, aqueous, dissolved. And the silver, the Ag, is now no longer dissolved, it's a solid form. So those experience some changes, and this is our net ionic equation. So what we're going to do is we're going to take a look at some definitions, and based on the net ionic equation, we're going to try to figure out which substance was oxidized and which substance was reduced. And then how do we know? So what this is actually a redox reaction. A redox reaction is a reaction where you have a transfer of electrons between substances. So typically one substance will gain electrons and the other will lose. And it doesn't even have to be complete transfers. It could be just the degree of sharing that changes between atoms in compounds. So one or more electrons are transferred. And during the redox reaction, when electrons are transferred, what that means is that two things happen. One thing must lose electrons and one thing must gain electrons. So we have terms for that. Oxidation is when a substance has lost electrons, one or more electrons, whereas reduction is where a substance has gained one or more electrons. And if you think about it in terms of charge. Reduction, electrons have a negative charge. So when you gain electrons, your charge is reduced, meaning you become more negative. So you can think of it that way, whereas oxidation is the opposite. As you lose electrons, you become more positive. Okay, so let's take a look here and try to analyze which reactant that we're dealing with was oxidized and which was reduced. So just a reminder, oxidized means there was a loss of electrons, and then reduced means there was a gain of electrons. So try to think about, in this situation, which of the reactants was oxidized, which was reduced. Pause the video, think about it for a bit, make a guess, and then we'll take it up. So hopefully you pause the video and you took a look and you made a guess. If we look carefully, it looks like the copper was oxidized. And what was reduced was the AgNO3, but specifically the Ag in there. In other words, the Ag plus AQ. So if you look carefully, copper was copper solid with a charge of 0, and then it became copper 2 plus, meaning a charge of 2 plus. So that means if it's positive, it must have lost electrons, and specifically, we're looking at probably 2 electrons it lost. Whereas silver was 1 plus, and then it became Ag solid with a charge of 0. So it was plus 1, and then it became 0. So that means that it must have gained 1 electron to make it a charge of 0 now. So gaining the electron was the reduction, and losing the electron was the oxidation. So that's how you could tell in this reaction which was the one that was oxidized and which one was the one that was reduced. So in the next video, we're going to take a look at the concept of half reactions. But for now, get the idea that if you have a reaction, especially these reactions that are single displacement or even double displacement based, what you must do is you write out the total equation. You write a total ionic equation so you can see charges and what's actually reacting and what's not. And you write a net ionic. And that net ionic makes it a little bit easier for you to see what was oxidized or reduced because you can see charges. So you can see that Ag plus went to Ag with no charge. And then Cu, no charge, went to Cu2 plus with a charge, which allows you to see that, okay, this must have lost electrons and this one here must have gained electrons. Therefore, reduction, therefore, this to this, oxidation.